Hello viewers, I am Dr. Robiul. I work as a lecturer in pathology in a medical college hospital, and I am making this video for my students and also for you. Hope someone finds this helpful. Today's topic is on aneurysm. Since aneurysm is a very big topic, so I will upload videos about aneurysm in two parts. In part 1 of this series, we will talk about the definition and various ways of classifying aneurysm with their description. In the second part of this series, we will finish our discussion by talking about the pathogenesis of aneurysm, followed by brief discussion about abdominal and thoracic aneurysm and their management. Okay, so a lot of topics, so let's begin. First question. What is an aneurysm? How can we define an aneurysm? So as written in your textbook, aneurysm can be defined as permanent, localized, abnormal dilation of the blood vessel or heart that is caused by congenital or acquired causes. So I am repeating the definition again for my students, and then I will explain. Aneurysm can be defined as permanent, localized, abnormal dilation of the blood vessel or heart that is caused by congenital or acquired causes. So now let's explain this definition. The first thing that you have to remember is aneurysm is dilation of blood vessel or dilation of the wall of the heart. The second thing that we have to remember is that this dilation is not happening in the entire blood vessel, or it is not happening in the entire heart. It is happening at particular area, at a particular portion of the involved blood vessel or heart. That's why it is called localized. And obviously this is not a normal condition, so that's why it is also called abnormal. And the next thing that you have to remember is that this is a permanent condition. Once an aneurysm has developed, it is not reversible without surgical intervention. So that's why it is called a permanent, localized, abnormal dilation of the blood vessel or heart. So always remember those 3 points: permanent, localized, and abnormal dilation. And the last thing that we will talk regarding this definition is it is happening due to certain congenital or acquired causes, and as a result of those congenital or acquired causes, portion of the blood vessel wall or portion of the wall of the heart becomes very weak, and in those weak areas gradually aneurysm tends to develop. So now that we have defined aneurysm and explained this definition, now let's look into this whiteboard. So on the far left of this whiteboard, you can see that I have drawn a normal blood vessel. So this is a very diagrammatic representation of a normal blood vessel. And look what has happened in the right side of this image. In this part of the image, we can see a variety of aneurysm, and we can see that they are happening as localized dilation. So we can see, for example, here is one dilation, here is another one, here is another one. So all these are localized abnormal dilation happening, and therefore these are aneurysm. So now let's talk about the classification of aneurysm. Now always remember, aneurysm can be classified in a variety of ways based on various features. For example, we can classify aneurysm according to the composition of its wall. We can also classify an aneurysm depending upon the shape of the aneurysm, and also depending upon the pathogenetic mechanisms of aneurysm formation. So let's talk about these various classifications one by one. So the first way to classify aneurysm was based on the composition of the wall of the aneurysm, and in that classification we can classify aneurysm in true and false category. So one is true aneurysm and the other one is false aneurysm. So what do we mean by true aneurysm? An aneurysm is considered a true aneurysm when all the three layers of the blood vessel wall or the involved heart wall is involved. So here recall that blood vessel has three layers. From inside to outwards, they are tunica intima, tunica media, and tunica adventitia. Similarly, heart also has three layers, and aneurysm, when aneurysm is involving all three layers of the wall, that is considered true aneurysm. So what are the causes of true aneurysm? Examples will include Atherosclerotic Aneurysm. Now I have two separate videos entirely dedicated to atherosclerosis, so you can also look into those two videos to know more about atherosclerosis. So atherosclerotic aneurysm is one example of true aneurysm. Other examples will include aneurysm that happens in tertiary syphilis. Another example is congenital vascular aneurysm. And true aneurysm can also happen in the heart following transmural myocardial infarction of the ventricle. So all these are examples of true aneurysm. Always remember these examples. These are very important for your examination. Moving on to the next type, and that was false aneurysm. So what do we mean by false aneurysm? The first thing that you have to remember is false aneurysm is actually not an aneurysm at all. The thing is, here there is a defect in the wall of the blood vessel or in the wall of the heart, and through that defect blood is getting out. So there is a defect, and due to that defect there is extravasation of blood outside the blood vessel. And recall that collection of blood or accumulation of blood outside the blood vessel is also known as hematoma. And the thing is, in this situation, once blood has gone out of the blood vessel into extravascular space, that blood is then confined to that space with the help of some extravascular connective tissue. Let me explain. So here I have drawn a false aneurysm. So this is drawn in red is the blood vessel. So since this is drawn in red, so obviously this is an artery. And look at this portion of the artery. We can see that there is a defect in this portion of the artery, and through that defect blood will go out of the blood vessel into extravascular space. So this is the extravascular space, but note that in the extravascular space there is extravascular connective tissue that I have drawn in this black color, and due to that extravascular connective tissue, blood is confined to this space and it is forming a hematoma, and there is communication of this hematoma with the interior of the blood vessel. So this thing may appear as if this portion of the blood vessel has become dilated, when in reality it is not actually dilated. It is looking like this due to the defect in the wall of the blood vessel. So this is false aneurysm. So what are the examples of false aneurysm? Where can we see such false aneurysm? False aneurysm may occur following rupture of the ventricular wall due to myocardial infarction, when blood is coming out through that ruptured portion of the ventricular wall but is contained by pericardial adhesion. False aneurysm may also occur as a result of leakage following vascular grafting procedure. Now let me explain. Suppose a vascular grafting procedure was done. So blood vessel taken from a particular site is now grafted in the affected vessel, and there are sutured junctions between the grafted vessel and the natural artery. And sometimes these junctions may become leaky, and that may result in development of false aneurysm as well. So now that we have classified aneurysm according to the composition of the wall, now we will move on and classify aneurysm according to its various shapes. And as you can see in the whiteboard, I have drawn a variety of shapes. So let's talk about these different types of aneurysms one by one. So according to shape, aneurysm can be classified as saccular, fusiform, cylindrical, serpentine, and racemose. So let's talk about these types one by one. So what do we mean by saccular? It's like a sac. In this type of aneurysm, there is spherical outpouching of a portion of the vessel wall, and usually it happens in a localized area of the blood vessel, usually on one side. The thing is that local area on one side of the blood vessel becomes very weak, and later it becomes dilated in a sac-like manner, and that results in formation of saccular aneurysm. This type of aneurysms will have various diameters, that is, they will vary in their diameter between 5 cm to 20 cm. And this type of aneurysm will often contain thrombus. Now I have a separate video entirely on thrombus and thrombosis, so you can also look into that video after finishing this video for more information regarding thrombus. The next type according to shape was fusiform aneurysm. Now look what has happened in this type of aneurysm. We can see that a long segment of the blood vessel is involved when we are comparing it with saccular. Recall that in saccular only a small portion was involved, but in fusiform aneurysm we can see that longer segment of the blood vessel is involved, and they are involved in a circumferential manner. Okay, so that is making a fusiform shape, and that's why it is called fusiform aneurysm. This type of aneurysm will also vary in diameter, and they can be up to 20 cm in diameter. The third type according to shape was cylindrical aneurysm. In this type of aneurysm there will be parallel dilation just like a cylinder. The next type is serpentine, and yes, you guessed it, in this type of aneurysm there will be tortuous dilation, and that's why it is called serpentine aneurysm. And the last type is Racemose aneurysm, as you can see here. This is example of Racemose aneurysm, and what will we have here? Here, the aneurysm will contain mass of intercommunicating arteries and veins. Another way of classifying aneurysm is according to their pathogenetic mechanism. And as a matter of fact, this type of classification is most often used. According to this type of classification, aneurysm may be atherosclerotic, syphilitic, dissecting, mycotic, or berry aneurysm. So let's talk about them one by one briefly. So the first one was atherosclerotic aneurysm. Always remember, atherosclerosis is a very important cause responsible for aneurysm. And the thing is, when there is atherosclerosis beneath the tunica intima of the blood vessel, that increases the traveling distance that oxygen and nutrients must travel when they are diffusing from the lumen of the blood vessel towards tunica media. So, since there is increase in the traveling distance, less and less oxygen and nutrients will reach the tunica media, particularly the inner side of the media, and that's why there will be ischemia on the inner media. The tunica media will become damaged, it will become very weak, so ultimately that will lead to aneurysm formation. So that is the mechanism responsible when we are talking about atherosclerotic aneurysm. Always remember that here there will be ischemia in the inner tunica media, and that will make the wall of the heart weak and result in development of an aneurysm. The next type was syphilitic aneurysm. Now, this type of aneurysm is seen during the tertiary stages of syphilis, and in your textbook you will see that during that tertiary stage or late stage of syphilis, there is some problem involving small vessels, and the term is obliterative end arteritis. Now let's think about this term, obliterative end arteritis. What does this term mean? So at the end of this term there is itis, end arteritis. Okay, so that means there is inflammation. And where is this inflammation taking place? It is happening in the tunica intima. So in the late stages or tertiary stages of syphilis, there is inflammation in the tunica intima of the small blood vessels, particularly the Vasa vasorums, and that is resulting in narrowing or obliteration of the lumen of these blood vessels. Now you may be asking me, Dr. Robiul, what do we mean by Vasa vasorum? Now Vasa vasorum is a Latin term. It means vessels of vessels. As a matter of fact, Vasa vasorum are network of small blood vessels that supply the walls of larger blood vessel. For example, the wall of the aorta. And in case of tertiary syphilis, there is obliterative end arteritis, that is obstructing or narrowing the lumen of these small blood vessels. So since the lumen is obstructed, or since the lumen has become narrowed, so the Vasa vasorums won't be able to provide sufficient nutrient and oxygen, particularly to the outer media. So that will result in ischemia of the outer media in case of tertiary syphilis. So in tertiary syphilis, the outer media of the thoracic aorta will develop ischemia that will make portions of the blood vessel weakened, and that will result in dilation and development of aneurysm in tertiary syphilis. Moving on to dissecting aneurysm. Now what do we mean by dissecting aneurysm? It is also known as dissecting hematoma. The thing is, in dissecting aneurysm there is some defect in the wall of the blood vessel, and then blood enters inside the wall of the blood vessel through that defect, and then it separates the laminar planes in the tunica media, and so there is development of blood filled spaces in the tunica media of the affected vessel. So that is dissecting aneurysm or dissecting hematoma. Always remember that in this condition there is defect in the wall of the blood vessel. Blood will enter through that defect inside the wall, and there it will result in development of blood filled spaces in the tunica media. Moving on to mycotic aneurysm. Well, as a matter of fact, in mycotic aneurysm there is infection, and that infection will result in weakening of the affected blood vessel, and that will result in development of aneurysm. Now you may be asking me, Dr. Robiul, how will this infection reach the blood vessel? How will we get mycotic aneurysm? So infection may occur in the blood vessel wall as a result of septic embolization, say for example as a consequence of infective endocarditis. Another example is when infection is spreading to the blood vessel from an adjacent site of infection. And another mechanism is when there is an organism in the blood, and they are directly infecting and damaging portions of the blood vessel. So all these three mechanisms may result in infection of a particular portion of the blood vessel, and then that particular portion of the blood vessel will become weakened, and that will result in mycotic aneurysm. The next type was Berry aneurysm, and here there is dilation, small dilations, and Berry aneurysm is particularly seen in the circle of Willis at the base of the brain. So this was in short about the classification of aneurysm, and this concludes part 1 of aneurysm topic. I will hopefully upload the second part within a week, where we will finish our discussion by talking about pathogenesis, abdominal and thoracic aortic aneurysm, and their management. Okay, so that's all for today. Until next time, take care and stay blessed. Thank you.